again, balancing chemical reactions is our theme. I'm going to work through sort of long strategies with lots of graphics, and then as you work your way through and master this skill, you're not going to do all of this writing and these symbols that I'm going to use. The law of conservation of mass will come up a fair bit through your chemistry and potentially physics. Firstly, whatever we start with, we're going to finish with. If we start with 100 hydrogen, we have to finish with 100 hydrogen. They may be in different chemicals. You may start with hydrogen in H2O and end with hydrogen in hydrogen gas. Okay? But the actual count of each of the individual atoms has to be conserved. So the total count of individual atoms. So we need, students typically learn this by seeing examples. So I'm going to balance the decomposition of water. Now, I've typed out what we call a skeleton or unbalanced reaction. All the chemicals are there, and we can't alter the chemicals because that's what reacted. We have water reacting, then we've got an arrow, hydrogen gas was produced, and hydrogen comes elementally in pairs. That's on your formula sheet. H2 is on your formula. Polyatomic elements just above your periodic table. They're elements when they're not combined with anything else. So hydrogen comes in pairs, oxygen comes in pairs when it's only that element. But that's not balanced. If you look at the O atoms on each side, there is one of them at the beginning in water, but there's two of them at the end. So that's why it's not balanced. We've invented something out of nothing, and that can't occur. So we're going to fix this. We're going to fix this by changing the count. Now, I already put blanks in front of each of these. Okay? That's the only spot that we can add numbers. Okay? I can't put a little 2 after this O because I wouldn't have water anymore. I'm changing the chemical, the H2O2, which is not what we're talking about. Now, to give an extra visual, most will not do this, but in your first lesson, I want to give you the visual representation of what's going on. So at the beginning, we have one water, and when I draw it out, you see all the atoms fairly clearly. We get hydrogen gas, which is 2 hydrogen bonded together, and we get oxygen. At the end, everything at the start has to equal all our products. Sometimes you'll do this count in your head, but I want to give you a visual tool, and most students are going to do a little before and after tally on your quizzes and your homework. We have reactants, we have products. At the very beginning, how many H's do we have? Okay. Well, there's 2 of them here. We've got the visual. There's the 1, 2 drawn out. Okay. Eventually, you won't draw these out. 2 hydrogen. We look on the product side. There's a pair. Okay. There's our 2 H's. So at the very beginning, our hydrogen is balanced. It's following the law of conservation of mass. But we're not done. O is not balanced. Reactants, products. We've got 1 O in water, and we've got 2 O's in elemental oxygen. So we need to get the count to balance. So the only thing we can do is add whole numbers in front. We can have 1 water or 2 waters or 10. So I need to somehow turn this 1 into a 2. And to do that, I would want to double 1 into 2. I'm going to write 2 times for a double. That's how I can get my oxygen to balance. What that looks like in our equation is a 2 put in there. When we just have a blank, we treat it as 1. I'm going to double that 1 to a 2. Now I have fixed my oxygen. Oxygen is balanced on both sides. What that would look like over here, by putting a 2 in front, I'm just saying there's 2 waters reacting at the beginning Now that messed up my hydrogen. I have to go back and fix that. I didn't change the product hydrogen count, but the reactant hydrogen count with the 2 waters, I've doubled that to 4. But I can fix that. I got 4 on this side. The product, I can double that to 4 by doubling my hydrogen. The visual equivalent is having a second pair of H's. Okay? And now my hydrogen is balanced at 4. My oxygen is balanced at 2. That is the balanced chemical equation for the decomposition of water. Now, the one thing I encourage you to do, but you don't have to, is blanks we treat as ones. I encourage you to write it in, but it's not required. Next year, your teacher's going to leave them out all the time. I encourage you to leave them out. Okay? But I don't want you to think that an empty blank is 0. That's the danger. It is a 1 until you put a number in. Okay, we drop all kinds of 1s. Okay? There is 1 oxygen here, but we don't write that 1. It's redundant. That's my first example. Second would be if you put sodium metal into water. We now have 3 different elements to balance. I'll do the visual representation underneath. So sodium and all metals come in 1s, except for mercury has lots of exceptions, and you're not going to see mercury examples. All the metals except for mercury come in 1s, and they're solids. Then we've got water again. So I'm drawing 1 of each, and then I'll figure out how many I need. Then I get sodium hydroxide and hydrogen gas. We'll start with sodium. Reactant side, there's 1 of them. On the product side, there's no subscript here, and we treat it as a 1 in front until we put a number. So there's only 1s around the sodium on each side. So sodium's okay. Next, I'll do hydrogen, and then last, I'll do oxygen. Now there's a question. Oh, the brackets are empty. I want to talk about states at the end. You mean this little gap? Yeah. Yeah, we're going to talk about the states before we finish this up. Hydrogen. We got a pair of hydrogen in water. On the product side, we've got 2 here, but then we got a 3rd over there. We can see 1, 2, 3 H's. So this question is going to be a bit harder because we got hydrogen in more than one place. Oxygen, water has 1, and our sodium hydroxide has 1. So our sodium starts okay, our oxygen starts okay, our hydrogen isn't okay. We somehow have to find a number that we can get the hydrogen to balance. Here they're coming in pairs. There we've got a pair and a single. So we want to find the smallest numbers that we can use to get these to balance. I can't just put any number. Well, here's my low side. Now we can have 1 water or 2 or 3. I've got to get this side up, and I've got to get it to a count that I can get on this side. Okay? So 1 wasn't enough. If I had 2 water, is there any way to get the product side to have the same hydrogen count? It would be 2 water. Each water would have 2 hydrogens. We'd have 4 in total. And we can get 4 H's on the other side. We've got 2 here, and I could put a 2 here and get 4 H's on that total side. So to fix my H, This is the low side that has to go up. There's just 3 on the product side. If I double this, I get 4. And before you put that in, you'd want to think, can you get 4 H's on the other side? There's the visual, 1, 2, 3, 4. And now if I stick a 2 there, I've got 1, 2, 3, 4. So sometimes you have to make a decision if there's the same element in 2 places, where do you need to manipulate to get them to balance? So my hydrogen, I got to update all my lists. I got 4, 1, 2, 3, 4. Sodium was okay, but I've changed things. There's still 1 at the beginning. At the end, there's now 2. What you're doing is taking the 2 in front, multiplying it by how many sodiums you have in each unit, which is 1, so 2 in total. My oxygen, I now have 1, 2. On the product side, oh, I still have 2, so my oxygen's okay. So I got to 4 hydrogen on both sides, that's good. I ended up making my oxygen balanced when I fixed the hydrogen. I'm just short the sodium. I need to double my reactant side. And that balances all my atoms. We're now following the law of conservation of mass. This is how this reaction is going to occur. You're going to need 2 sodiums to react with 2 waters. You're going to get 2 sodium hydroxide units, and there's no number here. That's a 1. 1 unit of hydrogen gas coming off. Now I said the answer to my last question, the state, all of these diatomics are gaseous. And your solubility table would tell you about sodium hydroxide. What each state is, we know it's being made in water. What does the solubility table tell you about hydroxide with sodium in water? So it's your last column in your solubility of selected ionic compounds in aqueous solutions. You go down to group 1 ions. It's the very first word. Is sodium a group 1 ion? Yes, it is. And if you go across, that's the aqueous heading for that row. So this is aqueous. You're going to have a nice clear aqueous solution with bubbles coming off. For a test or quiz, the only thing you need to report is what's in this red box. That is the balanced equation from the skeleton to the balance. Okay. You may do a little count of right and left like I did here. Okay. You may draw it out. By the time you finish this course, and particularly when you get to grade 12, you'll do a lot of this in your head, and you'll just write out the answer. I really encourage you today, try to at least do a tally. So if you make an error, I can come around and give you feedback. When you do it in your head, it's hard for me to give you feedback. And it's hard on a test to give you partial marks. So on a test, I really encourage you to do out a tally. They'll get harder. You'll get words, hopefully, from your quiz. Many need to practice a bit more of the naming, but that'll get better and better. And this one, we got to go from names to symbols and then balance it. So we start off with copper plus silver nitrate. So copper, that's a metal all by itself. Metals come in ones and they're solids. We saw that with sodium, one example of a metal all by itself. We're going to have to figure out how many coppers do we need to react with silver nitrate. Well, that's silver. Nitrate we've looked at, that's not an I, that's an 8. So that's one of those polyatomics. So eventually you'll probably memorize it, but you don't have to. You can look it up. That's NO3. I'm going to switch colors. You don't have to write the red, the charges, but you have to realize them. So you balance this formula unit. Silver on your periodic table is always +1. Nitrate's -1. So I don't need any subscripts. Okay, +1, -1, that's in balance. No, I'm not going to look at the solubility table. I remember that all nitrates are aqueous. We're going to make copper 2 nitrate. Not sure how many. Copper. There's the nitrate again. This is 2 plus. That's 1 minus. That's not balanced. The lowest common multiple between 2 and 1 is 2. So I want +2 and I want -2. Well, I already have +2, so I need 1 copper. I don't write in a subscript 1. I need 2 nitrates. When you polyatomics, you have to bracket the whole thing so you can double the whole thing. That's another. Plus silver, one thing all by itself, and the metals come in ones. I didn't quite have enough room to write solid at the end. So these questions are going to be longer. You're going to get 1 page for homework or classwork that's going to look like this skeleton with all the pieces for you. And then there's a whole page of word ones, which are much slower, require a lot of that naming practice. Now we're going to start balancing. Now, and I want to mention a shortcut in balancing this. When you have polyatomic ions, you can count them as a group as long as they don't break up. You could count nitrogen, and then you could count oxygen. But because all the nitrogen is a nitrate, and all the oxygen is a nitrate, I'm just going to count the nitrates. And if I have the same amount of nitrate on both sides, my N count will be balanced, my O count will be balanced. It's a shortcut by counting polyatomics. So I'm going to do orally. If we look at copper, there's 1 here and 1 here. This 2 only applies to the bracket. It doesn't apply all the way to copper. So there's no number there, it's a 1. So copper is 1 and 1. Can you wait till I finish? If you can't, you can go. So copper is 1 and 1 on each side. We look at silver. 1 silver, there's no subscript, so that's a 1. There's no number in front, so that's a 1. So everything around it is a 1. 1 silver, and there's 1 silver. So everything's okay so far, but we get to our nitrate. Here, NO3 is nitrate, and there's only 1 of those NO3 units. Over here, there's a subscript. There's 2 of them. Okay. So I'm not going to count the N and the O separate. 2 nitrates here, I want 2 nitrates there. Okay. I can't put a subscript in because I've already balanced the charge. I have to put a number in front to double my nitrate. Visually what I did, this side had copper 2 plus and had 2 nitrates stuck to it. What I just did to get it to balance was we have silver nitrate, and I added a second 1. So 2 units with 1 nitrate each, 1 unit, but it has 2 NO3s in it. But I've accomplished my balancing. 2 nitrates, 2 nitrates. My copper's still good. My nitrate's still good. Does anybody see any elements that aren't balanced? Pardon? Yeah, the silver is the last thing that isn't balanced. I'll fix that and I'm done. We've got 2 and a 1 after it, so 2 silver, and this is the visual of the 2 silver. We need 2 silver on this side, so I'll put a 2 in front. And now we balance this reaction. Copper, metal, so think of a penny. No, they're not pure copper anymore, but an old-fashioned copper penny plus silver nitrate makes copper nitrate, and we'd get solid silver out at the end. Last, I encourage you, you don't have to, I'll mark it right, but I encourage you to put those ones in. And we're going to use those ratios later in the week when we've perfected our balancing to make predictions. For every 1 silver, we get, one copper, we make 2 silvers, solid silvers. Okay? We can use these ratios to make predictions. Okay? We see a copper doubling to the amount of silver that you get. Okay? And that ratio can be used universally. I want to skip, this is a longer one. I'll leave it blank in your notes, but I want you to practice some before. So we're not into homework time yet. These are some reactions I'd like you to balance. I'll be coming around to see how you're doing. Yes, Hayden? Yes? I'll just pull all 4 of them up. Now, while you're practicing, if your neighbor next to you wants to help you, you are free to try to get some assistance. When you're all done, when you've done all 4 of them, on page 16 and most of 17 is a lot of practice. There's hours of practice there, more than you're going to do right now. I would get started on a bunch of 16, which looks like the practice on this board. Once you're comfortable, maybe you've done half of 16, you have high confidence, move on to 17, which is words to balancing, which takes longer. The bottom of 17 is a skill that we're going to learn tomorrow, predicting reaction.